Good morning to everyone. Up to now we have finished the PN junction diode construction and operation, and its voltage current characteristics, VI characteristics, and right now we are going to the application that is PN junction diode, which is used for rectification process. That is, we are in the topic rectifiers here. So, when you think of rectifiers, we should have a knowledge of alternating currents here. In our houses and many of the industries, we use alternating current, and in our houses, that is in electronic appliances, we use most of the electronic appliances used or they work on DC. So, there is a need to convert alternating current into direct current, because we need to reduce the voltage of that alternating current. So, we need to use some device which can convert the alternating current into direct current. So, that is what we are going to discuss about this, that is half wave rectifier here. So, let us see what is rectification first. The process of conversion of AC into DC is called as rectification here. And before this diodes, the rectification process is carried by vacuum tubes, and of course today they are using semiconductor diodes. Okay, so in which the unidirectional passes of current by the diode is utilized in converting this AC into DC. And let us see the construction, how the half wave rectifier gives the DC output voltage. Okay, so let us have the diagram here. So, if you see this diagram, what we can have on the left side here is input voltage. You can check this here. Here it is input voltage. Okay. So, input voltage, what is input voltage is given is AC, and this is AC is of the sine wave, and this half wave rectifier will have single diode, and you can check this diode here. Single diode is appearing here, D, and P type and N type is there, and only half cycles of input AC voltage will be converted into DC here. And here we need to have some point, that is we need to know about an ideal diode. So, what is an ideal diode? Which shows a zero resistance in forward bias and infinite resistance in reverse bias conditions. So, I repeat, this ideal diode, it shows the zero resistance in forward bias and it shows infinite resistance towards reverse bias. So, this working of half wave rectifier is also explaining on the basis that assuming this diode is an ideal diode. Okay. So, in the case of this particular left hand side of this diagram, what we are seeing here, here we have a particular block, that is the AC input is connected to what? The transformer. Here you can clearly check. So, a transformer which consists of core in between these two coils here. So, the coils here, this is primary coil and this is secondary coil. So, if you check the coils, you can have the question here, either the number of turns in the first coil and the number of turns in the second coil, they are less, or as comparison comes, they are bigger, they are longer. That is, the number of turns present in the first coil is less than or greater than the second coil. If it comes, then we need to know about the step up transformer and step down transformer here. But that would be discussed later when the transformer comes in the later classes. Okay. So, here the input, that is AC, is connected to the primary coil of the particular transformer, and then the secondary coil is connected to the diode P type. Here you can clearly see diode P type is here, and then in between these two, that is the secondary coil, second terminal S2 is connected to the load resistance here. So, why we are using a load resistance here? A load resistance, across a load resistance we will calculate the, or we will determine, or we will get the output voltage, that is VO, and input voltage here is VI. Okay. So, VI is given and VO is taken from RL, that is load resistance here. So once again we'll recall this, what is the construction. Half wave rectifier consists of a diode and a load resistance RL, which is connected in series in the secondary circuit of this transformer. And of course the polarity, what we say, the polarity of S1 and S2, you can see this S1 and S2, the polarity has been altered. That is, if S1 is given positive and S2 is given negative, that is during the positive half cycle of this input voltage, what happens here, this input voltage during this particular positive half cycle, S2 is given negative voltage. So under this condition the diode is in forward bias, that is P type is connected with the positive terminal that is given to S1, and then N type is connected to negative terminal, that is S2. Then the diode is said to be in forward biased. So the input current continuously flows through this S1 and only we will get the particular half cycle. So either you get it or not, once we will check this, right, once we will check this through another slide. So what is happening here, you can see this input voltage and input voltage VAC is the input voltage, and output is taken across the RL, and you can see the input voltage is continuous with the complete cycles. This is positive half cycle, negative half cycle, and again positive half cycle, and with a phase of pi, 2 pi, 3 pi, and so on. So next, if you check this output voltage VDC, that is direct current voltage, then we will be missing somewhat, that is the cycle is not continuous, so the pulse is discontinuous. Okay, so what happens here in this is, during this condition, that is empty condition, at which the diode is in reverse bias, we are using we are assuming that the diode is an ideal diode, then what we can say, this diode offers infinite resistance in the case of reverse bias. So there is no flow of current, there is no conversion, so that we will be obtaining somewhat discontinuity in the output. So if this happens like this, why it happens like this, we need to calculate.